Live. We are live. Good evening, good afternoon, good morning. Here is Baji. He had a late dinner. They had some snacks, late dinner. I felt very tired this evening, so we're a little bit late at going live, but we did post some short videos earlier, so hopefully you saw all of that. If you're joining our live right now, welcome, welcome. Welcome to the live. Thank you for being here. And if you're seeing this later on as a video upload, then also welcome, welcome. Thank you for watching. Thank you for all your comments on all of our videos as per usual. Thank you for being in the live stream. We did a long live yesterday on gamma ray bursts. I'm hoping that all of you saw it and you liked it and that you can check it out. Hello, hello, my love. How are you? Who is joining? Welcome, welcome. Welcome to the live, my friends. So let me share the live while we're at it, while I remember. So, and I also found that we did post this live on cosmic inventory. At one point we were talking about the cosmic inventory as far as cosmology topics go. Hi Goodwill, how are you? As far as cosmology topics go, we talked about the cosmic inventory, and I checked under the live tab on my channel that there is a live stream called Cosmic Inventory. So if you missed it, Fuji, uh-oh, party time again. Yes. Hi Goodwill, hi Doro Doro. How was your day? How was going back to work on the 2nd of January? I think that's what today was. Hi Goodwill. There's my live. Very good. Missed you. Thank you. I need to go. Tomorrow I should go live a bit earlier. But here I am. I couldn't go to bed without saying hi to you all live. Hi Ram Candy. Hi M Dot. Goodwill says hello, hello. Doris says party time. Very good, missed you. Ram Candy says hi. M Dot says hello, handsome. Sports fan says hi, hi. Dora Madness says work was quiet as it should be. Hope everyone is good. Yes. Brenia Robinson says hi, you're cute. Thank you. Thank you so much for joining, my friends. Thank you for being here. I wanted to cover another physics topic today, but I'm a little tired. And I did some work earlier today and whatnot. And oh, hello. I posted some more videos. And by the way, I'm going to schedule some more videos to come out. So hopefully you will see that as it comes out. And I saw Doro Doro, by the way, that I do have an episode under my live tab called Cosmic Inventory. And so sort of around there is the cosmology topics, including Cosmic Inventory, if you want to take a look at that. Do you like American football? Says Tunnel Divers. Hi, Grimace. Hello. Hope everyone has eaten McDonald's today. I have not, but okay. Mech Tonight says, hello, I only eat McDonald's. American football is boring. I love the Steelers. Tunnel Divers says, I love the Steelers. I don't know what that is, but okay. Banana Penguin says, I haven't because my mom and dad don't love me. I'm sure that's not true. Banana says, no, you should be loving the Lions, man. I am me says, yeah, American football. I am not myself a fan of American football, but I'm glad that you are. Me either. Okay, so there we are. I've shared the live now. Doro Madness is saying, I don't know. American football is pretty boring. I do like the Lions too. No, it's true. They hit me. Oh, Banana Penguin is saying, your parents don't like you because they hit you. Okay. The Texans aren't good this year though. Banana says, no, it isn't. I am me says, that's a lot of hair. Oh yeah, sorry. I was gonna take this rubber band off, but then I'm like, you know what? Let it be. It's kind of holding the hair, sort of. I'm kind of tired of brushing my hair. So it is what it is. Just kidding, they don't hit me. It's a joke. Tonight we got American football, some dude being hit by his parents, good old YouTube Shorts lives. What do you mean? Does this have anything to do with the YouTube Shorts lives? Or do you mean that this is part of the vertical live stream? Are you from India or Pakistan? Asks, I am me. What do you think? I am me? Tunnel divers, who agrees that the KC Chiefs are all luck and help from the refs? Is that an American, or sorry, is that a football question? Dora Madness, that's it, vertical live stream. Ransom's coming in, she's from Belgium. Oh, randoms. Okay, randoms coming in. I was like, dude, is there something about kidnapping now too? I'm so confused. Vertical live stream. Yes, this is called vertical live stream, guys. But that's okay if you don't know that. Only content creators should really know that it's called vertical live streaming. Belgium. Really? Really? Yeah, maybe. Yes. I have decided that Belgians talk like this. But that may or may not be misinformation. Belgium. Really? We're gonna be praising Mighty Mahomes with this one. Tunnel Divers says, crying emoji. What you crying about, baby? Is it windy outside? It is! Oh my gosh, how did you know? How'd you know? How did you know? It is windy outside. Are you a psychic? Banana Penguin. I am inside. Away from the natural elements, but it is windy outside. How did you know this? We're in Brussels. Brussels sprouts. Yeah, I am me. She's really from Belgium. She talked about it last night. Was shocked too. This is the greatest live feed ever. Thank you, I am me. Banana asked, is it windy outside? I know we live. We're in Brussels. And why the hell did your hairline go so far back? Who, my hairline? Why did your hairline go so far back? Are you asking me? Since we're talking boring sports, one time I fed a banana to a penguin. Today I'm just going to be reading your comments, so keep them coming. Let's see, what's the most interesting comment that we will get today? So, Dorodoro, you probably have work tomorrow. Do you live in Brussels, Belgium? I live in Brussels, Sprouts. I'm waiting for my friend to join who's actually from Belgium. I've decided that I will confirm where I live once my friend from actual Belgium joins. His name is Reese. I sort of do easy day, last one for a while. Gonna enjoy the final easy day. Oh yeah, tomorrow your final easy day. Okay. There is some... Hi! Hi, Ben. Good evening to you and your simply adorable cat. Thank you so much. He's over here. He's napping. Maybe he'll come into my lap soon. But currently... currently, he's napping over here. Hi, Danny. Danny says, hello. Hello, Danny. Hi, Ben. Ben Lujan, very kind of you. Dora says, all you newbies, you missed the nostril stream. That one got wild. That's true. You guys, after this live, you should go and check my live stream from last night or yesterday. And there were some nostrils that were involved in the discussion there. And indeed, these nostrils provided some entertainment. Tunnel Divers is saying Brussels is the capital of Belgium. Thank you, Tunnel Divers. Nostrils, Belgium nostrils. These are some Belgian nostrils. Nostradamus. So I covered gamma ray bursts yesterday. I got way too excited. And then today I did some stuff that made me kind of tired. So tonight I'm taking a chill pill. And I'm going to cover more physics tomorrow. And then Doro, it's going to be Saturday and Sunday when you don't have to work. So you can concentrate on my live stream. Before Monday hits you like a ton of bricks. Grimace says, I only use my Mac nostrils. Nostrils. Somehow I can't say that right. I only use my Mac nostrils. McNostrils. To smell McDonald's. What about the planets all aligning? Also, if you don't know, the capital of Monaco is indeed Monaco. By the way, now that you talked about the planets aligning, now I feel like talking about planets. Let's talk about which planets I'll definitely listen to the weekend lives while I'm rocking some stuff. Will be a good time. Thank you. So did you know the planets known prior to the invention of the telescope were Mercury, Venus, Mars, Jupiter, and Saturn, in addition to the Earth, of course, because we live on Earth. Without a telescope, the planets look like unresolved stars. Early astronomers distinguished them from stars by the fact that planets move relative to the stars. Ordinarily, planets move slowly eastward relative to the stars. On occasion, however, they reverse their motion and move westward relative to the stars for a short period. This reversed motion is called retrograde motion. We have an example of Mars retrograde right here, and this book is called Foundations of Astrophysics, written by Barbara Ryden and Bradley M. Peterson. I think, so somebody here might know about astrology. Isn't like Mars retrograde right now? So by the way, in astrology, I do believe, although don't take my word for it because I'm not an astrologer, I'm more of an astronomer. But apparently in astrology, Mars is the god of war, correct? Is that right? Am I saying that right? And so when Mars goes retrograde, some people expect people to be more volatile and like picking fights and sort of like creating chaos because it's like Mars is doing something to them. Yes, Mars is the god of war. Yes, that's what I thought. So Mars retrograde, by the way, which I believe is right now, and somebody talked about the planets aligning. So how apt. Mars retrograde looks like that. See, here's the book, and that's what the apparent motion of Mars relative to the stars during late 2005 and early 2006. Mars was in retrograde motion from 2005, October 1st to 2005, December 9. And somebody can look this up, but I think Mars is retrograde like right now. So, my hair is crazy, but yeah. McPlanet is the only planet that matters. Okay. So yeah, how interesting that I opened the book. Somebody mentioned planets. I opened the book to a paragraph about planets, and it's Mars retrograde right now, and this page had Mars retrograde in it. The Mars retrograde of 2005. What a coinkydink. Crazy hair needs a wild Ronald. It's fry grease combined with vodka. Okay. The great circle along which the sun moves on the celestial sphere is called the ecliptic. The ecliptic represents the plane of the Earth's orbit around the sun projected onto the celestial sphere. The ecliptic is inclined by 23.5 degrees relative to the celestial equator. The tilt of 23.5 degrees between the ecliptic and the celestial equator is called the obliquity of the ecliptic. The obliquity is non-zero because the Earth's rotation axis is not exactly perpendicular to the orbit of the Earth around the sun. Instead, the axis is tilted by 23.5 degrees from the perpendicular. Since the ecliptic and celestial equator are two different great circles on a sphere, they intersect at 2 points 180 degrees apart. The 2 points of intersection are called the equinoxes. So guys, we're going to now talk about seasons. The point where the sun moves from the northern celestial hemisphere to the southern is called the autumnal equinox. The sun is at the autumnal equinox around September 21. The point where the sun moves from the southern celestial hemisphere to the northern is called vernal equinox. The sun is at the vernal equinox around March 21. Can't wait! Can't wait for March 21. The days will be longer again here in the northern hemisphere, specifically in Belgium. The point on the ecliptic that is farthest north of the celestial equator, it has a declination of plus 23.5 degrees, is called the summer solstice. Yay, summer! The sun is at the summer solstice around June 21. The point on the ecliptic that is farthest south of the celestial equator, a declination of negative 23.5 degrees, is called the winter solstice, which we just had in the northern hemisphere. The sun is at the winter solstice around December 21. Astronomers usually use the terms equinox and solstice to refer to points on the celestial sphere. However, the terms can also refer to the time at which the sun reaches those points. Fall is the best season. Agreed! My birthday is in fall. I do agree that fall is the best season. I hope Mars never goes retrograde again and the world stays in peace forever. Yeah, so according to astrologers right now, even though we're reading about astronomy, apparently a lot of people might pick fights at this time because Mars is in retrograde right now. But that's an astrology thing. We're talking astronomy, but I thought I'd throw that out there. So if anybody is trying to pick a fight with you, it's because of Mars retrograde. And then just let it go. Did you know the capital of Turkey is Anarka and not Istanbul? I did not know that. Thomas Diamond's aunt. No one cares. What? No, I care. I want to know the capital of Turkey. Y'all are saying your own facts. I want to say mine. Who is y'all? She's reading a book about planets. Oh, that's okay. You can tell us about the capital of different countries. I don't give a damn. I want to say my facts. They did the final experiment. Of what? Which experiment? The sun's diurnal path varies during the year because its declination changes as it moves along the ecliptic. The time per day that the sun is above the horizon depends on where it is relative to the celestial equator. This is why we have some really short days in Boston right now. Oh, whoops, I'm in Boston, not Belgium. Same thing. Same thing. Okay, now I'm joking. That's true. I'm in Belgium. Hello. She's joking because she's really in Belgium. That's true. I love planets and all, but I also like geography. That's good. Oh. The final experiment in Antarctica to show the 24-hour sun to flurfs. They did it this winter. Hi, Yadav. Hi, Tunnel Divers. Hi, Doro Doro. Hi, I am me. Hi, Goodwill. Hi, Dr. CS. So, y'all, I'm really enjoying everybody's active participation in this chat. This is a great thing. Dominate the chat with all the facts that you want to share. It's a safe space for all facts. Hi, Fuji Baba. কি হয়েছে সোনা? কাঁদে না বাবু. What is it, Fuji? What do you want to tell me? Fuji is trying to say a fact as well about Belgium. Right, baby? Good job. Good job, my baby. Okay, we will go back to this. Yes. I think that's all good. The more engaged the audience is, the better. The sun's diurnal path varies during the year because its declination changes as it moves along the ecliptic. The time per day that the sun is above the horizon depends on where it is relative to the celestial equator. At the equinoxes, the sun is exactly on the celestial equator and thus spends 12 hours above the horizon and 12 hours below the horizon. Wow! When the sun is north of the celestial equator, it is above the horizon for more than 12 hours for a northern hemisphere observer. And we could have some really long days. When it's south of the celestial equator, it is above the horizon for less than 12 hours for a northern hemisphere observer. In the northern hemisphere, the shortest night of the year occurs when the sun is at the summer solstice, its point farthest north of the celestial equator. Similarly, the longest night of the year in the northern hemisphere occurs when the sun is at the winter solstice. So thankfully, since the winter solstice just passed, we're now on the up. Like, the days are actually getting longer for us here in the northern hemisphere. Believe it or not, the sun is still setting at like 4 something in Boston. So that is leading to some depression for people here. But soon the days will be longer, I promise, because of the facts here of astronomy. Hello, lovely. Hope your day went well. Oh, swell. Yes. Thank you. Thank you for joining Crazy Sick Wine. Oh my gosh, tunnel divers. Yes, tell us your facts. Sounds like they're going at it like a bunch of, but it helps your engagement, so that's kind of good. Thank you, Doro Doro. She wants to hear my facts. That's true. You should say more facts. We want to learn about geography as well. Me personally, I'll just but go off. Hello, lovely. Hope your day went well. Hi, Thomas. Crazy Sick Wine, how are you? So, all right. That's good. We will now. That was it? What? What was it? I know wine is much needed. The final experiment. Yes, I saw something about what you said. Let me look at it on my iPad, because the comments are going by with a vengeance. Oh, I see. Josephine loves Paris. I think I forgot to say hi to this person. Sorry about that. But okay, I can't find your message anymore. But thank you. I'm doing good. I got the day off today, so I'm kicking back. Pretty mellow evening. Good. Yes. I mellowed down pretty much as well myself. I was gonna go live earlier, but then I was doing some stuff and then I got really tired and I took a nap. Then I ate some food, I did some more stuff, and then here we are. Here I am. When the sun is at the summer solstice, it has a declination of plus 23.5 degrees and hence is a circumpolar star for observers north of latitude 66.5 degrees north. Within this region bounded by the Arctic Circle, observers experience the phenomenon within this region, observers experience the phenomenon of the midnight sun around June 21. The sun never sets but makes a complete circle in azimuth over 24 hours. At the same time, observers within the Antarctic Circle at a latitude of 66.5 degrees south never see the sun rise over the horizon during the course of 24 hours. At the time of the winter solstice, around December 21, the situation is reversed. Observers within the Arctic Circle have 24 hours of darkness, while observers within the Antarctic Circle have 24 hours of sunlight. I can personally confirm that this is the case because I was in Antarctica during the austral summer and we never saw the sun go down. It is true. It just kind of stays, it just makes a little, what was the line here? I thought within this region bounded by the Arctic Circle or Antarctic, observers experience the phenomenon of the midnight sun. The sun never sets but makes a complete circle in azimuth over 24 hours. So it kind of stays at the same sort of like elevation, but it makes a circle in azimuth and pretty much does not set. So like we would work all day, you know, eat dinner, go to the bars, come out of the bars at like 2 in the morning in Antarctica. There's like 3 bars at McMurdo Station, which is the biggest station in Antarctica, and the sun would still be up. So I've seen my midnight sun and 2 in the morning sun. I'm good, bro. Just relaxing now before bed, watching people go at it in the chat. Goodwill says exactly. Oh yeah, the trolls are maniacs. You know, everyone's just doing their thing. Definitely jealous. I'd love to go to Antarctica. So I think the normal people go there, the way of going is some cruise, right? So I've heard people actually go sort of to Antarctica on with like tourism ways. I think a cruise is involved and they go basically to South America and then they keep going down until they reach sort of Antarctica. So it's not quite the same part of Antarctica that you would be at, I think. Cruises, I'm out then. Cruises can disappear. Yeah, so I didn't do cruises. I didn't go there on a cruise because I went there for work. So I'm talking about what I've heard people say in terms of tourism in Antarctica. I think the only time I've heard normal people going there normally for a tourism type of reason is a cruise. I didn't do a cruise because I went there for work. So I went there from New Zealand on a C-17. So that's probably not going to be your way of going there if it's a tourism thing. But if you work there, then there is definitely a way of getting there. What are your thoughts on the existence of aliens from a physics perspective? And did you see anything strange in Antarctica? So I'll just say that, did you know that the people who do like alien research, like people who are looking for life on Mars, or um like people who basically do, so by the way, I was not in Antarctica to do alien research or like life on other planets type of research. I went for ANIDA, Antarctic Impulsive Transit Antenna. It had to do with particle astrophysics, so completely different stuff. But I did meet scientists who were there, other scientists who were there, to do more like alien research, if you will, or basically looking at very extreme environments and like what type of life can thrive there. So because Antarctica is like the place on Earth that is most like un-Earth-like, there's actually a fair amount of research going on there where the scientists who are interested in those types of questions actually go to Antarctica to see, like, in those very extreme environments, what type of life is supported by those extreme environments. Even the Southern Ocean, I've heard. So don't quote me because I'm not the expert on this topic, okay? But this is just what I kind of picked up on when I was there. No one thought you went to Antarctica to research aliens, but no, people do go there to research aliens. I mean, aliens is just life on other planets, right? So basically, if you wanted to, say, figure out in, say, like Mars, right? Mars is a different planet, extraterrestrial, obviously, right? So like ET is just extraterrestrial, right? It's actually, aliens might not be that interesting, guys, because it could literally be just some kind of like, I don't know, some algae or something that grows on a different planet, right? Not all aliens are something cool. So basically, so it's more of a like a biology question. So there are people who go to Antarctica and research. There's also some very dry, let me get this right. I think they're called dry salt lakes, maybe. Basically, all these like glacial things there and those like salt lakes or those dry lakes or whatever in Antarctica, stuff that I'm not an expert on, those places are actually the very good places on Earth for people to go and research aliens because they want to understand what kind of life is supported in these extreme environments. And I also heard that the Southern Ocean is home to a lot of different species that are sort of like the size of these things are bigger there than in other parts of the planet. So anyway, let me read your comments because yeah, even the penguins there are big, right? The emperor penguins are bigger than Fuji. The emperor penguins are bigger than some of the other penguins that you might have seen in other places. That's awesome. I'm no scientist. I just yell at numbers while my secretary watches in horror. Ooh, fancy. You have a secretary. No one thought you went to Antarctica to research aliens. That's hilarious. I mean, I could have. Laughing with you, not at you. Needs to have a I want to believe shirt on tomorrow or a poster in the background. No, aliens are always interacting. I've seen Mars attacks. I've played Mass Effect. Seriously, I love aliens and the idea of them being out there. This sounds more interesting than quantum physics for sure. Grimace says mech aliens. I know. We need to have McDonald's for the aliens. So yeah, a fair amount of people actually research aliens in Antarctica. So if that's of interest, you might want to join those types of research groups. But that's what I heard when I worked there. But I did not myself research aliens, and I myself did not have a big focus on. Ooh, that's right. I saw that seal. There's like a little, like a hole in the ice at a point in McMurdo Station, and you can climb down it, and you can basically see the ocean surrounding you. And I saw a seal. There's lots of seals there, little mommy seals. Actually, no, pretty big seals. Mommy seals and baby seals. So if you're interested in seals and all these different species, again, I'm not even getting into it in a lot of detail, but pretty much the life that is supported in Antarctica and around Antarctica is special and is studied by a lot of scientists who are basically, they extrapolate from there towards life outside of Earth. So there might be a connection between aliens and Antarctica, but I don't know. I don't know much. Do you believe in time travel? What do you mean by that? So yeah, but yeah, I was part of the particle astrophysics group there. So nothing to do with life for me. I'm from the future, so yes to time travel. Indeed. Indeed. Their food is about to be... Fuji, you were looking for food. Here it is. There you go. Okay. Is it possible? Not that I know of. Time travel? We're all traveling in time. Like, if you mean that, can we go back in time? Can we go to the future, like in a science fiction type of way? Then my answer would be, I don't know about that. What do you know about the Big Crunch hypothesis? But if you mean time as the fourth dimension, then yes. Yes, indeed. Time is a fourth dimension. We talked about that a lot in my live stream called Einstein's Equations, and some other live streams as well. The Einstein way. Yes. The Big Crunch hypothesis. I don't know. I don't know much. Ooh. I can tell you, I can talk about the Big Bang. I don't know much. I don't know what to say about the Big Crunch. I don't know if that's a thing. Shall we? So I know I've talked a lot about quantum mechanics and relativity. Let's talk about Kepler's laws. Oh, I was just asking how you feel about the empty space outside of our universe. I don't know. That's so I am answering seriously as well. I don't know about the empty. I don't know what that is. I only know about the universe. I don't know about what is outside of the universe. Not to my knowledge. Let us now talk about Kepler's laws. Because I feel like I have neglected classical mechanics on this channel. I've talked about quantum, relativity, all sorts of things, but I haven't really talked too much about classical mechanics and planetary motion. Look up Mike Markham, interesting. He was an electrical engineer that constructed a Jacob's ladder. Okay. All right, Kepler's first law. Yay, Kepler. Planets travel on elliptical orbits with the sun at one focus. The properties of the closed curve known as an ellipse are best described by explaining how to draw one. Take a piece of string and tie each end to a pin. Stick the pins into a piece of paper, separated by a distance less than the string's length. Use a pencil to stretch the string taut and draw a complete closed curve. This is an ellipse. Yay! The two pins are located at the foci of the ellipse. Expressed mathematically, the ellipse is the locus of points for which the sum of the distances to the foci is a constant, equal to the length of the string in our graphic example, which we'll show here. See? That's an ellipse. So, if the pins are moved closer together for a given length of string, the ellipse becomes more nearly circular. If they're moved farther apart, the ellipse becomes more flattened. The longest distance across the ellipse, which passes through both foci, is called the major axis. The shortest distance across the ellipse, passing through the ellipse's center, is called the minor axis. The semi-major axis is half the major axis, and the semi-minor axis is half the minor axis. The eccentricity of the ellipse is the distance between the foci divided by the length of the major axis. If the foci coincide, then E is equal to 0, that is the eccentricity, and the ellipse is a circle. The other limiting case, E equals 1, represents the case in which the foci are separated by the full length of the string. It was quite a feat for Kepler to discover the elliptical shape of planetary orbits, since most planets have orbits with small eccentricity. Of the planets known to Kepler, Mercury had the largest eccentricity of E equals 0.21. All the others had E less than 0.1. Yes! Johannes Kepler. Wow! So that was the first law. Let's say the first law again. Planets travel on elliptical orbits with the sun at one focus. That's the first law, and then we talked about what an ellipse is. So, done with that first law. Second law! Kepler's second law. Aww, my little Kepler. Second law. A line drawn from the sun to a planet sweeps out equal areas in equal time intervals. Wow. This law provides a quantitative description of how the orbital speed of planets changes with their distance from the sun. Not only is motion not circular, Kepler discovered, it doesn't have uniform speed either. The second law is graphically demonstrated in figure 2.18. We'll look at it in just a second. A mythical planet has its motion plotted during 2 time intervals, each 10 days long, separated by half the planet's orbital period, the two wedge-shaped areas swept out by the planet-sun line are of equal area, even though they're of different shape. Kepler's second law implies that planets move most rapidly at perihelion, the point on their orbit closest to the sun, and least rapidly at aphelion, the point farthest from the sun. Let's look at the picture. Here it is, equal areas in equal time intervals. So, line drawn from the sun to a planet sweeps out equal areas in equal time intervals. That's the second law. And we looked at it just now. Only thing saving us is McDonald's. On Mars? Yes, are you going to put McDonald's on Mars? Kepler's third law. The squares of the sidereal orbital periods of the planets are proportional to the cubes of the semi-major axis of their orbits. Yeah, no, Kepler really was. Kepler was awesome. Yes, Goodwill. Agreed. Because look at all this work he did. Dora, what's your favorite fast food? People really like McDonald's in the US, man. Us Belgians wouldn't know. I'm from Belgium, so I don't really know. But Americans, they love McDonald's. The squares. Okay, Kepler's third law. The squares of the sidereal orbital periods of the planets are proportional to the cubes of the semi-major axis of their orbits. Kepler's third law can be expressed more compactly in mathematical notation. P squared is equal to Ka cubed, where P is a planet's sidereal orbital period, A is the length of the semi-major axis of its orbit, and K is a constant. For objects orbiting the sun, K is 1 year squared per astronomical unit cubed. A plot of orbital period versus semi-major axis shows that all planets in the solar system, even those unknown to Kepler, follow his third law. Amazing. Raising Cane's. Yeah. Me too. I eat a lot less fast food nowadays. I don't think I can digest it as well as I did in my younger days. DA Ghost, good evening. Hi, DA Ghost 417. Welcome. Welcome back to the live. So, how cute is Kepler's third law? Seriously. The squares of the sidereal orbital periods of the planets are proportional to the cubes of the semi-major axis of their orbits. Just amazing. I love it. P squared is equal to Ka cubed. Younger days, Grandma on 3B investigating aliens in Antarctica. No, seriously. Johannes Kepler died in Regensburg, Germany on November 15. Oh no. Although Galileo's discoveries convinced many individuals that the heliocentric model was correct, definitive proof that the Earth revolves around the Sun and rotates on its axis wasn't provided until much later. The rotation of the Earth about its axis was proved by detecting the Coriolis effect. This was done most famously by Jean Foucault using what is now called a Foucault pendulum. The revolution of the Earth about the Sun was proved by detecting the effect known as aberration of starlight. Later confirmation came from measuring the annual parallax of nearby stars. Did you just kiss the cube? Yes. I kissed the cube. P squared is equal to Ka cubed. From now on, I'm Goodwill cubed. Yes, indeed. Those were the 3 laws, guys. The 3 laws. Aw, thank you, Goodwill. Okay, so I actually... Oh my gosh! We will talk about the Foucault pendulum. I don't know if I'm saying this word correctly. I told someone today that humans are nothing but integers and variables. I guess it all makes sense now. P squared is equal to Ka cubed. I have to use the bathroom. 1 second. I'll be right back. Oh gosh. I feel something and it's not good. 1 second. I'll be right back. It's an emergency. Oh God. Oh God. Oh God. Oh God. Oh God. Here we are. Thank you for your patience. Oh, the boys went to find me. Oh, I didn't take the tablet with me. What happened here? Keep Anne. What? Excusez-moi. I had an emergent situation. Now I'm back. I'm reading your comments. The tablet was here, so you didn't make my tablet ding upstairs. That's how big this emergency was. I can see that. I can see what you guys have been up to. As I was in the bathroom, I was thinking, like, I wonder what they're saying while I'm gone. I'm gonna go read it. But as you said, I am developing a disease now. Except this beautiful proton, she's a quantum. Jeez. Oh my gosh. I hopefully did not take 45 minutes. We got time. Yeah, no. Yeah, I didn't bring my tablet. It was actually an emergency. We should discuss... Oh gosh. She sees all of this while in Belgium. That's true. That's true. She's quantum. Okay, no, you guys are most very very kindly putting up with each other. Thank you so much. We will go back to I didn't even bring my tablet up this time. Okay. Ooh, the revolution of the Earth. So, no putting up. The regulars are cool. Glad I got interaction with you guys this week. Thank you. Yes, thank you so much for being here. The aberration of starlight was first detected by Jean Picard. Oh, look at that. 1680. So old. The thing about classical mechanics is it's so old. But it wasn't explained until 1729 by the astronomer James Bradley. Bradley from Belgium. Just kidding. The aberration of starlight is an effect that causes the apparent position of stars on the celestial sphere to be deflected in the direction of the observer's motion. The common analogy to explain the aberration of starlight involves running through a rain shower with an umbrella. Even if the rain is falling straight down, you have to tilt your umbrella in the direction of motion in order to keep your head dry. Similarly, in order to catch photons from a distant star, you have to tilt your telescope in the direction of motion. Photons travel at a large but finite speed of light, 3 times 10 to the 5 kilometers per second, or 10 to the 8 meters per second. The orbital speed of the Earth averages of around 29.8 kilometers per second, which is about 10 to the minus 4 C. So if your telescope is 1 meter long, then during the time it takes light to pass through the telescope, the Earth's motion will have translated the telescope through a distance of 0.1 millimeters. Wow. Goodwill says you're cool, Doro. Yeah, Doro is very cool. So are you, Goodwill. So then, oh, this figure will tell you about all that. See, basically, here's this figure with all these lines pointing towards the Earth orbiting the sun, all that. So that shows that the angle through which the telescope must be tilted is given by the relation. Ooh, Doro probably knows all about this. We're discussing geometry, Doro. Your favorite subject. They were making fun of me. Back at you. Thank you. Hi, M. So, Doro will know all about this particular topic we're now talking about. So we have this relation, tan theta is equal to V over C. Since the Earth's speed is so much smaller than the speed of light, we may use the small angle approximation, and we get a theta of around 20.5 seconds. Aberration of starlight causes the positions of stars in the sky to follow an annual path, that is the projection of the Earth's motion onto the sky, an ellipse of semi-major axis, 20.5 seconds, and a semi-minor axis, 20.5 seconds beta, where beta is the angular distance of the star from the ecliptic. My favorite subject, I don't know about that, but I can talk some. Geometry is not your favorite subject? But you're an architect. It has to be. Or wait, maybe I don't know. Stellar parallax was introduced earlier, whatever, when we emphasized the fact that observers could not detect it prior to the invention of the telescope. In fact, even after the invention of the telescope, it took a long time before stellar parallax was first measured. It wasn't until 1838, more than 2 centuries after the first telescope. So 1838, wow. Yeah, more than 2 centuries after the first telescopes, that the astronomer Friedrich Wilhelm Bessel, anybody know Bessel functions? Announced that he had finally measured the annual parallax of a star. Formally, astronomers define parallax pi seconds as the apparent displacement of a star in arc seconds due to a change in the position of the observer by 1 astronomical unit perpendicular to the line of sight to the star. I use math for a living. My favorite subject is definitely not math, but it can be cool. It can be really cool. Like science, without math, our infrastructure would crumble. It is definitely cool, as well as equally vital. Like burning ants with a magnifying glass. What are you talking about, Nicholas? Oh yeah, okay. I'm glad that somebody is talking to Nicholas and asking what he's talking about, because I'm not sure I know either. But yeah, no, thank you so much for engaging. So, okay, so we looked at that a little bit. Let me talk about another thing now, which is the Coriolis. Science is the best thing humanity did. Doro Madness has the money bags here. As an architect, he has the monies. He will pay for rooms. Definitely not Miss Scientist. What? I don't believe you. Okay. The middle term on the right-hand side. Oh, wait. No. I don't want this. A celebrated demonstration of the Coriolis effect is the Foucault pendulum, first demonstrated in the year 1851 by a French scientist named Jean Foucault. A Foucault pendulum is nothing more than a long pendulum suspended from a ball and socket joint overhead, so it is free to swing in any direction. Although Foucault set up his own pendulum in Paris, it is easier to visualize the principle behind the Foucault pendulum if we imagine one installed at the Earth's North Pole. If we set the pendulum oscillating, it will continue to oscillate back and forth in the same plane as viewed by a non-rotating observer. Thus, a sidereal non-rotating observer would report the Earth rotates counterclockwise, viewed from above the Earth's North Pole, completing one rotation in a sidereal day. The plane of the pendulum's oscillation is not rotating. However, an observer co-rotating with the Earth would report, the Earth is not rotating with respect to my frame of reference. The plane of the pendulum's oscillation is rotating clockwise, completing one rotation in a sidereal day. So that's interesting, right? What Foucault did. Oh yeah, there's a lot of roses here. And red. Oh, those are lips. Kisses. Okay. Embolat. I'm poor compared to you. I just saw a bunch of red. I do have money, but definitely not Antarctica research money. You know, they don't pay a lot when you do research. What's up, Baji? Hi. Bloat. I think it's bolat, not bloat. But at first when I saw that, I was like, bloat? Please hold it for a while. I thought you meant like, I'm bloated. Please hold on. I have to go to the bathroom. But okay, now I get it. Goodwill. Bolat just wants to spam. He's got to get the gooning out. This is not TikTok, you know. What's up, Baji? Hi, Mad Hatter. What are we discussing on an introspective level? So, you know, today's live has been developing organically. We are just talking about planets today. Just a little bit of classical mechanics. Usually we cover, you know, physics. We've covered some relativity, modern physics, quantum mechanics, particle astronomy, astrophysics, and cosmology. But we have not done too much classical physics. So I thought we'll do a little bit of just planet stuff, Kepler's laws, and things like that today. The Kepler mission also helped to promote the funding of ground-based transit surveys, which are now successful in finding and characterizing exoplanets. Good job. Okay, so now. Let's talk about, actually, I think that, hi Fuji, Shona Ashbe. Fuji, you want to sit on Mama's lap? Hi Fuji, baby. So, the beginning part of this chapter is actually quite, I think it's quite... Ooh, we actually covered a little bit of this chapter in the past. I remember now. We talked about Ptolemaic astronomy and Copernican astronomy in the past one time. This chapter is kind of like what we're doing now is kind of a continuation of that, actually. It's part of the it's part of the same chapter. I'm not Nicholas. I'm not engaging with trolls. Mad Hatter said, okay, very good. I'm listening. Okay, thank you. Thank you so much. Nicholas, we have strong memories. This is a very engaged chat, indeed. So we kind of talked about the Ptolemaic astronomy. It was a lot. Actually, Ptolemy, that type of astronomy was kind of hard. They made the geometry very, very complicated, remember? So then we, of course, talked about Copernicus, put the sun at the center, heliocentric model. We talked about Galileo, the first modern scientist. Pretty amazing stuff by Galileo. Ooh, and we talked about, actually, we might repeat Galileo's main contributions here tonight because those are really nice. But then, we talked about Kepler. Really, the Kepler stuff comes after the Galileo stuff that we had talked about earlier, several lives ago. And so it's almost like we did a bit of a continuation. But yeah, let me read this part. Kepler's laws of planetary motion. So if you go back into the live, you'll see we talked about the 3 laws of Kepler. Kepler's laws, first law, second law, third law. We already did that. Now, let's look at this little introduction we skipped earlier. As increasingly accurate observations of planetary motions were made, the flaws of both the Ptolemaic and Copernican models became more evident. So we saw that the Ptolemaic astronomy was making things very complicated. Remember, the geometries were just so difficult. But even Copernican models had some issues. Tycho Brahe, who lived from 1546 to 1601, was probably the greatest astronomical observer prior to the invention of the telescope. It was his observations of planetary motions that both revealed the inadequacy of the Copernican system and provided the necessary data for calculating the true nature of planetary orbits around the sun. Because the heliocentric model wasn't fully accurate either. Tycho was a Danish aristocrat, so he was a rich guy, and received large sums of money from the King of Denmark to set up an elaborate observatory on the island of Ven near Copenhagen. For more than 20 years, Tycho observed the positions of planets and stars with an accuracy of 1 arc minute, which is pretty good, an arc minute. Interestingly, Tycho did not believe that the heliocentric model was correct. So he was doing all these observations and he was very motivated, maybe because he didn't fully believe in the heliocentric model, which is interesting, right? It's like, that's why we say that physics and astronomy are an experimental science, because it's almost like what you go in believing might be something else, but then you actually have to actually analyze your observations and look at your data and see what it tells you. And regardless of your beliefs and what you may have thought or not, your motivation could have been that maybe the heliocentric model is wrong, but we will see. Then you find out, right? So interestingly, Tycho did not believe that the heliocentric model was correct. He noted, as did the Greeks before him, that the stars do not show parallax. The absence of parallax is larger than 1 arc minute implies that the nearest stars must be farther away than a few thousand astronomical units, given a heliocentric solar system. Tycho thought this distance was implausibly large, and thus devised a compound system in which all the planets other than the Earth went around the sun, while the sun orbited the Earth, carrying its entourage of planets along with it. So he came up with another whole thing. And he was thinking that maybe we are special and that the Earth is sort of at the center, so to speak. In the year 1599, after a major falling out with the Danish king, from whom he was receiving his funding, Tycho accepted a post as imperial mathematician to the Holy Roman Emperor in Prague. Oh my gosh. So he fell out with the Danish king, but then he accepted a post as imperial mathematician. So that was his title. I wish that we got such titles. Imperial mathematician to the Holy Roman Emperor in Prague. There, he hired a new assistant named Johannes Kepler, who lived from 1571 to 1630. Initially, Kepler was frustrated by Tycho's reluctance to share his data. So, Tycho went to Prague because he had a fight with the Danish king who was funding him. But then, and then he got a new assistant in Prague, and he had collected, so Tycho did collect a ton of data. So that cannot be taken away from him, you know. But a lot of people who collect a bunch of data, sometimes experimentalists, those cats want to be on stream. Yes, they're all over here. They're all over here, but sometimes they're on my lap. Oh, there's some stuff on Fuji's back. I'm gonna have to get that. Tycho had a bunch of data that he was being a little possessive about. Initially, Kepler was frustrated by Tycho's reluctance to share his data. However, Kepler soon had complete access to Tycho's observations. In October of 1601, less than 2 years after Kepler arrived in Prague, Tycho died, and Kepler was appointed his successor as imperial mathematician. So look at that. What a destiny change for Kepler. Yeah, seriously. What a destiny change. Tycho wasn't really sharing, so I've heard this story before. Tycho wasn't really sharing his data with Kepler. Come, Baji. Right? He was kind of like holding on to it. And what he had thought was kind of like wrong. So if he had continued to not share his data and let Kepler kind of like inherit his data and analyze it. So this happens a lot, right? You might come into a project kind of at a later stage, but what? According to her, I'm mega rich, so I'd rather be here. Oh, yes. Hello. Hi, Peter. So, sometimes in a project, you might not be the owner of that project, but you sort of inherit it. And then you have the opportunity to take a lot of ownership, especially if the possessive original owner of the project dies. So in this case, Tycho died. And so initially Kepler was frustrated by Tycho's reluctance to share his data. However, Kepler soon had complete access to Tycho's observations. In October of 1601, less than 2 years after Kepler arrived in Prague. So pretty much Kepler didn't have to wait very long, because after 2 years of arriving in Prague, Tycho died, and Kepler was appointed his successor as imperial mathematician. By using Tycho's observations of the planet Mars and by doing several years' worth of calculations, Kepler was able to formulate a mathematical description of its orbit, and by extension, the orbits of other planets. His basic findings are encapsulated in Kepler's laws of planetary motion. Excellent, just amazing. Can you believe this? Tycho is the one who collected all the data, but because due to destiny, fate, Kepler is his assistant, Tycho was not really sharing his data, and Tycho had sort of other ideas that may have been wrong, but it still motivated him to collect all this data, which is of immense value. And then Kepler spends several years with it, and also Kepler inherits this data and inherits his position because Tycho dies. And that's how we get Kepler's laws. isn't that just mind-blowing how things can happen? This is just I love this story. It's sort of like this destiny change for science as well as that person. It's sort of like if Tycho had lived, I don't know what he would have done with the data, and I'm guessing eventually Kepler would have gotten a hold of it. But all the timings kind of lined up where Kepler became his assistant and inherited his position as well as the data. If he didn't have all of that data, that would have been very bad. Did Kepler pay the inheritance tax? I don't know, but yeah. I mean, come on. We got Kepler's laws of planetary motion, the first law, second law, third law. I mean, all of that. Like, remember Ptolemaic astronomy, the wrong stuff, right? Geocentric model. Then we get Copernicus. Then we get Galileo, who gives us very awesome things. But even the heliocentric model wasn't completely accurate. And then there were still people who were probably being a little bit doubtful. And so without Tycho's immense amount of data, it would have been hard. It would have been impossible. Basically, astronomy is also an observational science, it's an experimental science. So without collecting all that data and then analyzing it and spending a lot of time analyzing it, we would not have Kepler's laws of planetary motions, planetary motion. So this is amazing. Yes, things are okay, Peter. How are you? I just think that this story is amazing, and it gives, just so you know, it's really about stepping up. Sometimes in science, your career, it's really about it's he's a lucky assistant. Not every assistant is gonna get this opportunity, right? Because basically Tycho collected a lot of data and then he died, which gave Kepler the opportunity to inherit his position as well as the data and analyze it. So it's not just about being lucky. Then he put in the work of years and years of analysis to then give us Kepler's laws of planetary motion. So this is quite amazing. And sometimes actually a lot of good science come from these big bodies of work and being sort of associated with it, right place, right time, and then of course putting in a lot of work. When you respond to them, you make their day. So, so yeah, I thought that was such an amazing story. Anyway, let me also tell you about Galileo's contributions. We've covered this in the past, but I think Galileo is so Mad Hatter says, what is it about physics that made want to pursue this particular field to such a degree, respectively? I'm impressed by the devotion of those guys. Yeah, Tycho and Kepler, you mean? Yes. It takes so much effort to collect all that data, and for so long too. Like Tycho was a really, really good observational astronomer. Basically, it doesn't really matter what theory you have in your mind, right? It doesn't really matter so much about your motivation. If you're going to be a really good observer, if you're going to do really, really awesome observation and you're going to collect the data and you're going to stay consistent and you're going to put in all of that effort, then you have the data. Then it's up to either you or someone else, your assistant, whoever, can actually analyze the data. And then, so it's really, what played out here is really how science works, right? Like Tycho may have had his own thoughts and motivations as far as why he was collecting the data, but that's not important. The doing of the science is important. The collection of that data in a consistent, scientific, accurate, manner, and also over the course of a long period of time, giving us a collection of data that was actually useful, that was then used to analyze. This is the process. This is a scientific process that was carried out by both Tycho Brahe and then Kepler, which gives us these brilliant results. The three laws of Kepler are really the results of this, right? But all of that body of work that was done by each one is what makes the results possible. And that's the reminder that we have to think about, that it's all this work that eventually might give you such results. And you might even build on somebody else's work. So it's fine to come in at a later stage and still take that work and then do with it what you will, because that's how you carry out science and that's how you progress science. So this is just a brilliant story about that. I love it. But yeah, I mean, in science, you can't give up. You have to keep on going. So anyway, what is it about physics that made you want to pursue? Theoretical physics has been at a halt for over 30 years now. Much progress has been consistent, but in the early 19th century, it was such a romantic, beautiful time in physics. Yes, I think you mean the 20th century, actually. You mean in the 1900s. Like in 1905, we got special theory of relativity, photoelectric effect, Brownian motion, and was that all? I know we got like four big things in 1905. So, and then Einstein worked on general theory of relativity. So, I mean, so yeah, space-time being relative, mass-energy equivalence, photoelectric effect, and Brownian motion were all published in 1905. So the richness of the early 1900s, like that first decade, 1910s, 1920s, is you're absolutely correct that a lot happened during this during that period. It's a really rich period. We actually spent a lot of time on these live streams talking about that particular period. I think mostly in the month of November, if you go back to my live streams in the past, under the live tab of my channel. So we talked a lot about that period because, as you said, it's a very, very, very rich period. You are right that basically, if we come to our current times, the big sort of leaps that we have made, the big progresses that we've made are more in experiment and instrumentation and measurement. Our ability to measure and instrument, it has vastly improved, but there might not have been as much progress and richness in theoretical types of work. Yeah, I think I would tend to agree with that. He paid twice by mistake. Who? Oh, yes. So now let's talk about Galileo real quick. Even though we have Galileo we're going sort of in the other direction. We talked about Galileo in the past, but let's do it again. So, so Galileo lived from 1564 to 1642. Galileo is sometimes called the first modern experimental physicist. Instead of relying purely on the pronouncements of Aristotle, Galileo tried to understand how nature works by carrying out experiments, such as swinging pendulums back and forth and sliding weights down inclined planes. Although Galileo didn't invent the telescope, he was among the first individuals to use a telescope as a scientific instrument. The actual inventor of the telescope may possibly have been a Dutch optician called Hans Lippershey. In October 1608, Lippershey applied for a patent on what he called a kijker, or looker in English. The patent was denied by the Dutch government, however, on the grounds that many other persons had a knowledge of the invention. Indeed, news of the telescope reached Galileo in Italy as early as May of 1609. Soon thereafter, he built several telescopes, each superior to the one before. Although Galileo's telescopes had apertures of only an inch or two, they provided Galileo with many important observations. Galileo, knowing the potentially revolutionary impact of his discoveries, rushed into print in March 1610 with a pamphlet entitled Sidereus Nuncius, Starry Messenger. Many of Galileo's observations were startling to his contemporaries. So Galileo knew how to publish. This is another thing. In academia, we say publish or perish, right? Basically, you want to get good results and then you want to publish, or you're not going to get the revolutionary impact that you might be hoping for. At least Nicholas is Googling relevant stuff. Some other guy was putting capitals of various areas in the chat. You know, the capitals are better than some of the other comments we've gotten here. And yes, thank you, Nicholas. Galileo di Vincenzo was an Italian astronomer, physicist, and philosopher. He's often called the father of modern astronomy and the father of modern physics. Wow, look at you, Nicholas. Thank you so much. Nicholas, you should continue to tell us more about Galileo and Newton and Copernicus. In fact, we did not talk too much about Copernicus. We've covered him in the past. You should put something in the chat about Copernicus. Love it. But yes, I would rather take Galileo and capitals of various areas than some other things we've seen. You're hungry? Oh, McDonald's? Yeah. Oh, don't get me started on that. So, this is what Galileo observed. The moon is not smooth and perfect. Instead, as Galileo wrote, it is uneven, rough, and crowded with depressions and bulges, and it is like the face of the earth itself, which is marked here and there with chains of mountains and depths of valleys. In other words, there is not a vast difference between the earth's surface and that of a celestial object, namely the moon. Number 2, the Milky Way, the nebulous band of light that extends around the sky, actually consists of numerous faint stars. To whatever region of it you direct your spyglass, Galileo wrote, an immense number of stars immediately offer themselves to view. Number 3, through a telescope, stars remain unresolved points, but planets show as disks. As Galileo put it, the planets present entirely smooth and exactly circular globes that appear as little moons. Unfortunately for astronomers, even the nearest stars are too distant to be resolved with conventional telescopes, even telescopes much larger than Galileo's. Number 4, the planet Jupiter has 4 large, bright satellites. Although Galileo called these satellites the Medicean stars, or Medicean, I don't know, in honor of Cosimo de' Medici. Oh, it's definitely Medicean. Although Galileo called these satellites the Medicean stars in honor of Cosimo de' Medici, Grand Duke of Tuscany, later astronomers named them the Galilean satellites. The individual names of the 4 Galilean satellites are, quiz question, Io, Europa, Ganymede, and Callisto. That's okay. So the Galilean satellites, or the moons of Jupiter that Galileo discovered, the 4 large, bright moons of Jupiter that Galileo discovered were Io, Europa. Europa is, of course, very famous at this point, a big research topic, Ganymede, and Callisto. Nearly 70 at the time of his trial, Galileo lived his last 9 years under comfortable house arrest. Yeah. I use physics to harass. Oh, yeah. That's right. Indeed. He died in Arcet 3 near Florence, Italy on... By the end of the year 1610, Galileo made another telescopic discovery that further undermined the Ptolemaic model. He found that Venus went through all the phases that the moon did, from full to new. So, because seeing Venus's phases would be kind of hard, right? The moon is pretty big, so we actually notice its phases really well. Venus, you would basically need a telescope in order to, and you know, good thing that this guy basically invented slash improved upon the telescope. He found that Venus went through all the phases that the moon did, from full to new. So full moon, you know, new moon, that sort of thing. But new, it's a full Venus, new Venus. Moreover, he found that the angular size of Venus was smallest when it was full. This is the catch with Venus, right? He found, what the heck? What do you mean? Or are you talking about the comment? Yeah, okay. He found this, what I missed when I just listened. Yes, you miss a lot, Dora. Dora, you've seen nothing. You've seen nothing. So Galileo found that Venus went through all the phases that the moon did, from full to new. Moreover, he found that the angular size of Venus was smallest when it was full and largest when it was a thin crescent. So I'm going to show you the picture in just a second. The phases of Venus, illustrated by Galileo in his later work, 2 Saggiatore, are shown in figure 2.15. We'll look at it. Ptolemy, in his geocentric system, had the task of explaining why Venus should always lie within 46 degrees of the sun if the two bodies were on independent orbits around the Earth. Ptolemy managed it by saying that the center of Venus's epicycle always lies directly between the Earth and the sun, and that the epicycle is big enough to subtend an angle of 92 degrees as seen from the Earth. The geometry of this situation requires that we see primarily the nighttime side of Venus, that is, the side away from the sun in the Ptolemaic system. Then we would always see a new or crescent phase for Venus. But Galileo demonstrated that we see gibbous and full Venuses as well as crescent and new Venuses. This is easily explained in the Copernican system. In the Copernican model, the sunlit side of Venus is turned toward us when Venus is at superior conjunction. This is when Venus is at its greatest distance from Earth, and hence has its smallest angular size. Conversely, the nighttime side of Venus is turned toward us when it is at inferior conjunction, when it is closest to Earth and has its largest angular size. This is in accord with the observations of Galileo. Gladys, hi. Hi Gladys, how are you? I'm back. I haven't watched your lives in a long time. Yes, missed you. How are you? So that's the picture. These are the phases and relative angular size of Venus from crescent to full. So here you go. See how Venus is smallest angular size when it is full and biggest angular size when it is a crescent. Isn't that interesting? But basically Galileo did, this is one more thing he did, one more contribution that he gave us, which is the phases of Venus. Pretty nice, right? Venus along with Mercury. I think Venus has moons. Let me check. Oh, maybe not. Oh, you're right. Huh. Venus has no moons, making it and Mercury the only planets in our solar system without them. However, Venus does have a quasi-satellite named Zuzvi. Great. Okay. Good job, Nicholas. Keep on sharing. I saw you being racist. Okay. Anyway, welcome back, Gladys. Thank you, everybody. Oh, can someone please like the live so that I get 10 likes? Okay. So that was about Galileo. So today we covered Kepler's laws. We covered a little bit about planets in general. When we got started, we talked about Mars retrograde in terms of astronomy. We also talked a little bit about astrology, actually, because we might be in Mars retrograde right now, which astrologers are saying may have effects on people. Then we talked about Kepler's laws, Kepler's first law, second law, and third law of planetary motion. We talked a little bit about the rotation and revolution of the Earth and seasons and aberration of starlight and things like that. We also went back and talked about the story of Tycho Brahe and Kepler, and how Kepler was the assistant and inherited Tycho Brahe's position, as well as his massive amounts of data that helped him to give us Kepler's laws of planetary motion. Just amazing. And then we realized that we cannot miss talking about Galileo because he's just amazing as well. Gave us so much, as well as, he's the first modern scientist. So we talked about his contributions as well. Again, we've talked about it in the past as well. So that's what we covered today. Liked it. Oh, thank you. Thanks, Annie Frank. Happy New Year. Thank you. Happy New Year, Gladys. I'm still defending my honor. You know, Nicholas, from now on, at every live stream, you should keep on telling us more facts about Kepler, Tycho Brahe, Galileo, and the planets of our solar system. And that will be pretty amazing. So you should continue this streak. Could you please stop? Nicholas will be talking about Galileo and astronomy now constantly. He has agreed. So, good job, Nicholas, and good job, everybody, today. Everyone was so engaged, and we had a good time. Thank you for liking the live. Thank you so much. Thank you for liking the live. So yeah, you know what? I realized that we had covered a part of this chapter, quite a big part of this chapter in the past at one of our lives. I think maybe a December live. We've done a lot of lives. So we covered about the Ptolemaic astronomy and the Copernican astronomy, and Galileo, but we hadn't really talked about Kepler's laws. So we did that today, so that's a really good thing. We covered this now. Guys, his plan just worked. Whose plan? Gladys, thank you for the emojis. So we pretty much finished this chapter from, by the way, this is the book I've been referencing. This is called Foundations of Astrophysics. Looks like that. We pretty much finished this chapter. This was chapter 2. It was called Emergence of Modern Astronomy. And it starts all the way back to the Greeks, early Greek astronomy, Ptolemaic astronomy, all of that stuff. So we pretty much covered all of that, a little bit going backwards from Kepler's laws. So we made an incredible dent today into all of that. Thank you everybody for all your contributions and engaged chatting in the live chat. Nicholas has been telling us has been sharing a lot of facts about Venus, Mercury, Galileo, and whatnot. And he is trying to redeem himself, which I do appreciate. Engaged troll warfare in the chat tonight. Goodwill and Dorodoro, as usual, thank you so much for your support. Grimace, thank you. Gladys, great to see you. Everybody, thank you for being here. All the regulars, thank you so much for joining. Mad Hatter. I think I forgot to answer Mad Hatter's question. I think they asked something about picking physics. Physics is my favorite subject, so that's why I picked it. Foundations of Astrophysics is a good book. Yes! Love it. So happy to participate while I can. Of course! Yes, thank you so much. All my love. Oh, thank you guys. Thank you, thank you, thank you. Thank you, thank you, thank you. If you guys want to hang out, we still can. I'm going to get up though and get myself a drink of a water, some H2O, and continue to say hi to everybody, and we can continue to chat while people get ready for bed and for tomorrow. What? You and the McCrew, I'll buy you a room. Yes, we have a rich friend here. Mr. Richie Rich, which is a good thing. I wish you all the richest this happy new year. You should. Hi, Olomaro. Hello, Olomaro. I'll change my name again to Rich Doro. Exactly. Doro Doro. Richie Rich. Can you talk about birds scream? Birds scream? I'm not sure what you mean. Our M friend didn't come. Our M friend? Oh, do you mean our Belgian friend or do you mean the Thousand Roses? Happy New Year! Super Wang, I haven't seen you in forever. Where have you been? Oh yes, the Belgian. Belgium is not here tonight. I've had to represent Belgium. Me. I had to represent all of Belgium tonight. The Belgian guy is not here. Super Wang, how are you? Where have you been, my friend? I was ready to stay on this one, but I have to change it now. Oh yeah, your name? Buddha Open on YouTube. Okay. We're representing all of Belgium. The three of us, Doro Doro, Goodwill, and I, still remember Belgium and hold Belgium in our hearts. Oh, can you talk about birds next live? I really don't know much about birds, Gladys. I wish. I don't know. I think, yeah, I really don't know much about birds at all. My dear Gladys, you might have to. Ooh, but I have a friend who joins these lives who actually owns some pretty interesting birds. I haven't seen her in a while either. I'm trying to remember her username. I think it was Callie. Something about blue parakeets, maybe. I have a pretty good memory. So pretty much I remember the people who join, especially if they're engaging. And yes, we might have talked about birds at one point because of her. But me, I don't know about birds personally much at all. You know, my grandfather used to have birds though. You kind of reminded me of him now. He liked birds. In fact, I think he had some parakeets himself. I actually didn't know that they were called that, but yeah. So Gladys, are you studying birds? Doro says, laughing emoji. Goodwill says heart. Thank you. Thank you, everybody. I'm going to be around. I'm going to get myself a water. We can keep chatting and catching up. Thank you indeed. I'm a little hot. I might take this outer sweater off. Oh, I know. I was going to make some hot water. Maybe let me do that. Maybe I'll do that. Oh, where's my remote? This was fun. It was really fun catching up with everybody today. I feel like we discussed some nice things, some more classical things, planets and stuff, and then there was a very lively chat indeed in the live stream chat. So that was cool. Very cool. Ooh, you can look at Baji. Here's Baji Baba. Here's Baji. You definitely are. Oh wait, what do you mean? I'm definitely what? Look at that. Here is Mr. Baji. Yeah. Oh, Baji. Doris says Goodwill. I'm falling in love. Oh. Here's Mr. Baji baby. Falling in love. Well, so far, I have not been very lucky in that particular department. Right, Suji Mama? Oh, some dishes here. Look at Baji's little face. Oh, such a cutie. Baji Baba. 222. My microwave says 222. 222. It's 222. Fuji Baba, do you want a little snacky? You had a snacky. You had a snacky, my baby. Little Baba. To be sure now. To be sure now. To be sure now. I'm trying to give you a snack, but you're... Look at what they're doing. Look at what they're doing. I'm trying to give you a snack. Pretty. Yes, Baji Baba. Yeah, he's a pretty Baba. He's a pretty baby, and so are these babies. He paid twice? What does that mean? You're good, Nicholas. Come to some more lives. Do you have to pay for Googling? Okay, babies, you can have a little snacker. Little snacker. Baji. Fuji. Here you go, Fuji. I want Baji to run because he is better at hunting for snacks. There. I'm gonna change their water. I'm gonna change their water. Ooh, I got 13 likes. Can somebody like the live so I can get 15 likes? Maybe 20 likes. How about that? Tuk, 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 tuk. Like. This is Miss Suji. This one. Hi, Fuji Baba. I know. Here you go. Weren't you the one that got inspired? that actually was racist towards the Jewish faith. What? Just making my dinner and a cup of tea. Hi, Peter. Peter, how is Australia? Tell us about Australia, Peter. Guys, Peter is from Australia. He has a farm there. Dinner and a cup of tea makes sense. Yay. He too is in Belgium, that's true. Peter, you're actually Belgian. Fuji. He's not in Australia. Very wet outside. Oh, is it raining? Oh yeah. Is it raining in the summer there? That makes sense actually. I need to visit. Australia is on my list, honestly, to be honest. Trying to keep dry mash. Belgium. Yeah. No, seriously. Australia is on my list. I want to visit. Oh, Baji! Baji! Baji, Baji! Everyone should double tap the screen. I did. Look at Nicholas. He's being such a good citizen of this live chat today, of this live stream today. Everybody double tap the screen. Nicholas said to. You know, Nicholas is usually so bad, but today he has really redeemed himself. He has redeemed himself. I've seen everything now on this live stream. I must say, everything, Baji, Baji Baba, Baji Baba. Baji Baba is ready. 5 minutes away from the beach. Here's my tea boiling / water. Here's the water in Belgian accent. I live in New South Wales, Southwest Rocks, 5 minutes away from the beach. I'm literally your neighbor here in Belgium. Yeah, yep, yes indeed. That's cool, you're close to the beach, Peter. That's awesome. Southway. Let me take a note of that. South Wales. New South Wales. Southwest Rocks. Okay. So mashed potato, fresh onions, and salt and pepper, and ketchup, tomato sauce. I ate all my chicken before. She's making notes, a hit list. Exactly. Of Belgium. Oh my gosh, you guys. You're so funny. You're so funny. Look at Suji. She's ready. She's ready to pounce. You're funny. Okay, New South Wales. Oh, Suji needs privacy. Top 10? What do you mean? Top 10 what? You are funny. Y'all are really funny, I must say. Look at this baby. Hi, baby. Top 10. She is my top 10. Top 10! Alright, you guys. Change of water for the kitty cats. Hit the like button, guys. The like button. Top 10. Top 10 countries. 3355. 33. Is there something about McDonald's still? Fresh water. Hi. Who said nostrils? I've enjoyed this stream, especially Nicholas combating the trolls and the awesome time, but I'm going to bed. Everyone have a good night. No Belgium. Nostrils. Good night, Doro. See you tomorrow. Good night, sweet dreams. See you tomorrow. And we will pick up nostrils and Belgium tomorrow. Bye. Good night. Look at us. We even have some inside jokes now. About nostrils and Belgium. Okay, I changed the kitty cat's water and I gave them a snack. I think I'm gonna make myself a drink of warm water with something. And yeah, thank you everybody for joining the live. If you go back into the live, you will see our astronomy discussion of the day. We talked about planets, Kepler's laws, Galileo, Tycho Brahe, Kepler, all of that. So if you go into the back direction of the live, you will see all of this discussion, and then you will see us goofing off and chatting. So thank you for joining the live. Thank you for finding our live stream, and welcome, and go into it. Go into our discussion if you go back. And here is Baji. Oh, actually, I have a herbal tea here. I might try that. I have a herbal tea. Look at that. Tulsi mango peach tea. I think I'm gonna try this right now. Oh, hi, Fuji. Hi. I see. Kind of want to take this hand out. Kind of want to. Oh, man. Oh, no. Fuji is up to no good. Fuji. See how dry this got? It's an oil. Based situation going on here that I want to throw away. Fuji is helping, let's just say. Scraping the pan. Fuji. Hi, Fuji Babu. Now I can make my tea. Make my tea. Yeah. Your kitties are so relaxed tonight. Yeah. Yeah, thank you. Thank you, thank you. Thank you, thank you. Look at that. She's over here. Almost bedtime. Almost bedtime for us. Almost bedtime for us. I think I'm just gonna have this. Have a little calming tea. It smells good. The tea smells good. Like that. It does smell like mango peach. Smells like mango peach. That's for sure. Too bad we can't share smell on these live streams. Oh wow, yeah. I have some herbal tea going now. Gotta go. Hope you have a nice good night. Good night. Thank you for joining. Next time, too, I want more Galileo facts from you. Galileo, Copernicus, thank you so much. Okay, what are we doing? Yes, I'm checking that things are off. Up and vertical, off, 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 and off. Fuji, this is very hot tea. Be careful. Very, very hot. Very, very hot. Hello. Okay. I'll be sitting over here. Oh, okay. Can still see Baji. Baji. Good night. Good night, Ben. See you tomorrow. Good night. Good night and see you tomorrow. Yes, thank you. Hi, Baji. What did you guys find? Oh my gosh. What is that? Alright, Baji, Suji, Fuji. I thought they found a mouse. It's too late. We cannot get into any more trouble tonight. Too late, babies. Too late. Just finishing my tea. If you're joining the live, you can go back and see the full live. Baji, Baji, don't mess with the little robot. Baji. Baji? Baji, no? My God, Baji. Baji, what are you doing? Baji's playing. Look at this. There's a big drama happening here. Huge drama. They're playing. Look at Baji. Wow, Baji. So much action in the middle of the night. So much action in the middle of the night. All right, Baji. Baji. Are you gonna say goodnight? Say goodnight.